Is a deeper question altogether, which is, what do you desire? What makes you itch? What sort of a situation would you like? So I always ask the question, what would you like to do if money were no object? How would you really enjoy spending your life?
marijuana smoke. While I take totes of the marijuana smoke, so you in a choke, gun smoke. For mayor, the rap player, the overlayer, motherfucker, say your prayers. Hail Mary, full of grace. Smack the bitch in the face, take a Gucci bag and a North Face off her back. That's what she act. Funny with yo, you got me mistaken, honey.
From philosophy into science. There's knowledge advance.
Is anything wrong? Everything's all right. All right, so hi everybody, welcome. We're getting started a little bit late, but finally, welcome guys to BackEnd DevOps PH. We've been holding this event basically every other month for most of the year so far. It's a relatively new group, so thank you all for joining us here in Levis and at Split Media Labs. Hooray, Split Media Labs! Woo, thank you guys. All right. So we've been waiting on some different speakers to get here. One is still on the way, one just arrived, and one's already here. I'm going to go ahead and give a talk that I usually do for some of my classes. So who am I? I'm just a guy, right? I'm a guy who does a bunch of these different communities. We do Manila JavaScript, we do BackEnd DevOps, we do Analytica, we do FinTech PH, we do a bunch of stuff. And at night, I usually give classes. So I usually give classes on back-end, front-end, and data science, depending on the crowd. So what I'm going to be doing is I'm going to be filling in a spot for back-end web. And basically giving a concept. This is something I usually give to more amateurs, people who are just starting to learn, especially Node, learning the concept of how the web used to work on the back end to basically how it starts to work now. So for the more advanced people, this might be review for you, but for a lot of beginners to intermediate, a lot of this is new or very prescient knowledge. All right, so we'll go ahead and get started for you. Do I just like press the buttons? Yeah. Okay. All right, so there we go. All right, so we come from a world, and we work with different universities, we work with different companies, I get tons of different developers in these different events and stuff, and so hundreds and thousands of different developers, especially here in the Philippines, have these concepts of what the back end really is. And usually it's things that you guys learn in school, things like MS SQL. Where you have like this server that's built in with a database, and it's very, I don't know, you have to pay for a license sometimes, and all this other stuff, and you have your HTML and CSS, and it links up to some massive entity that controls everything else, right? Well, that's basically how things worked, through the 90s and early 2000s, and that's great. But it turns out lots changed since then. Eventually, we split the database from its backend, and then we've actually gone in the last few years and started splitting things even further. These aren't new concepts. These concepts have been used for literally generations. But in terms of their popularity and how often they're used, as the internet has become more and more popular and people get more and more access to these technologies through open source and other means, we have to learn these new paradigms. We have to learn these different paradigms rather than just what our teachers told us back in school. Right? So we'll start out with the standard web. Right? So what we basically know is something like, oh, there's some kind of monolithic app, right? Some kind of backend that's a server mixed with like a giant database, and it basically handles all the logic for basically anything we want to do, any kind of app that we're trying to build. And the real discrepancy there is, am I going to do it like a two-tiered approach or three-tiered approach? I might have some middleware, and that's like a huge concept that people try to integrate into this. But still, it's a very simplistic kind of model. The reason I say it's simplistic, and the reason this is something that happened earlier on, is because we didn't necessarily have the tools or the population really starting to develop the know-how, the tools, and the other libraries and stuff that help us split this up. And why would we even want to split this up is, well, maintainability, really. I mean, security is another thing. There's a lot of different things that are happening in this giant monolith, and the monolith is just like this giant, the thing from, what's the movie with the apes, right? Where the apes, it's the dawn of man and whatever. Planet of the Apes. Right? Not Planet of the Apes. It's the futuristic one. You guys. No, 2001. Yes, thank you. All right, yeah. But yeah, so there's like the monolith, and the apes are like, woo, and they don't know what this thing is, right? And that's essentially what this is it becomes like a giant black box with a lot of codes fitting into it, and that's what a lot of your different apps look like and do look like, and especially like banks and stuff, right? I used to work at a bank, a couple of investment banks and stuff, and yeah, you look at their code, and it is just a mass of different languages, tools, libraries, over generations of literally 50 years, right? Of people just adding on and hacking into it, right? It's not easy or fun to deal with, right? So there are advantages to splitting these up, right? So two-tiered, it's nice, it's all in one place, keep it just the HTML and CSS and everything else in the back, okay, fine. You split it up a little bit more, you can actually separate some kind of tasks, right? You can build that middleware that can deal with certain kind of things in terms of, different functionality, different services, whatever you're integrating with, right? But this is in general an older concept. This talk in general is about Node and how Node can actually help with some of this stuff. And that's what our company uses. We use Koa in particular. But Node itself is a framework for JavaScript. And it lets you do back-end JavaScript, essentially. And then there's different frameworks you can use on top of that. You don't necessarily need to use just Node. You can use Express, Happy, Koa, Sales, other things. Right? And then there's the idea of APIs. Usually I have to cover with students. What is an API? You have no idea how often nobody knows what those 3 letters mean. Right? That's essentially how systems talk to other systems. Right? Hooray! Right? So I know the Split guys, they know this stuff, right? I know my guys know this stuff, but often you'd be surprised. Like we just gave a talk at San Beta, right? Last week, right? And nobody knew what an API was. Nobody really knew what JavaScript was, right? So these are CS majors, these are IT majors. It's scary, right? I know, but this is the life we have here, right? So we have to educate and we have to go through these concepts and really understand what individually everything does and not take it for granted. Right? So anyway, we talk about different things like, so how does the web work? How do our services eventually talk to each other? We use things like HTTP, right? Just one of many protocols we use. Otherwise, we typically use like things like TCP, other kind of things, HTTPC if you want to. But when we build APIs, we build it on this concept of REST. So REST is representational state transfer, but essentially it's just a formalized way of building an API, right? So it's essentially stateless, so it doesn't really care what kind of data you're passing through it. It's usually going to be some kind of XML or JSON, and then it uses verbs, right? So it uses things like get, post, put, delete, things like that. And there's like 20 of them, right? And basically, this is a nice way that people just recognize as, oh, I can totally use this. I just pass stuff into it. It should be pretty idempotent, so it just does something that I expect on the other side, right? And blah, blah, blah. That's just how it looks, right? So other concepts for the newbies, right? These are questions I get. I've built these whole set of slides only because of questions I've gotten in my classes, in these events, and just walking around the streets. Right? So what does a client do? It requests. What does a server do? It responds. That is very difficult for new people, right? And so just understanding that the client is going to do some kind of, and it's not necessarily like a browser. It could be the mobile app. It could be just another service somewhere that's initiating some kind of request. It's requesting some kind of data, right? From some kind of data source, usually, a database, if you will. And then whatever that database is, or whatever's tied to that database, whatever service or servers tied to that, will respond with something, right? It'll give us some information back. Whatever you wanted, hopefully it knows what that is, and it'll return it back to you, right? So basically, the browser, the client, and the server will talk, request and respond, blah, blah, blah. In terms of those different verbs I talked about, there's different ones we have. Things like get, post, put, patch, delete, right? They all do different things. So they all have different meanings. They're all different in terms of idempotency and then data safety and whether or not they're cacheable. But essentially, they do what you think they do, right? So get receives, basically asks for the information to read it somehow. Post will actually send a new cache of information or payload of information. Put will update whatever it's targeted towards. And then patch will update only a part of it. And then delete will delete it, right? So in terms of safety, basically the only thing that's safe is get. It's the only thing that doesn't really change anything. If you want to know what idempotency is and stuff, and you want to go more into like caching and safety and stuff, talk to me afterwards. There's plenty you can go into for that kind of stuff, right? So the responses, they respond basically the same way. So basically, it's going to be something like telling you what protocol you're using, giving you some kind of server response. Usually a 200 means OK, we like it. And then there's a bunch of other stuff that fits in the header. It's a lot of wasted space, but sometimes someone might want to parse that for something. And then it goes into the body. So if I'm opening a web page for the first time, this is one of my interview questions for literally when we're hiring, is what happens when I first load a web page? And so many people just don't know, right? So it's it's doing a bunch of things, right? It's targeting an IP, and it's going through and finding that DNS, and then it pulls something out of that, and then it starts loading things, but it tokenizes and parses and does a million things, honestly. But what it's first doing is it's checking for any files that are there, right? So if there is an HTML and you're on the internet, right? So you're going to some URL, it's looking for the HTML, right? File, and then it's going to pass that in the body, and then it's going to go through that and look for anything that's it'll pass in any CSS it sees, but then it'll pass in a script, and the script will check for any other CSS that's dependent on that JavaScript, right? Blah, blah, blah. And when you've asked for that HTML or the CSS or the JavaScript or whatever, at least on the web, it's going to give you some kind of response. And there's different responses, and on the back end, we're supposed to handle that, right? So there's different kinds of 400s, there's different kinds of 500s. There's in some languages still, in like Node and PHP and a few others, I think there's like which one is it? It's like 413 error or something like that. It's I'm a teapot, right? And so that's, I mean, it's just a random thing. But there's a lot of different versions of these different kinds of responses you can get, and you handle them in different ways depending on what they are, right? Talking about HTTPS, HTTPS is the way we essentially encrypt the internet as we know it. So basically, we sign a certificate. There's a central authority that handles that. There's a bunch of stuff for this, right? But basically, this is the way to encrypt transmissions of data across the internet. So there's some kind of special thing called a certificate that's signed by an authority. And there's a handshake that takes place, a key exchange. I'm not going to go too deep into the security side of that. I did that last BackEnd DevOps, or 2 BackEnd DevOps ago. So I'll avoid that for right now. But there's an idea of there's a little bit more work that's happening, right? So I can't necessarily access anything I want to, especially if it's encrypted. And the idea is not necessarily that the data source is encrypted, it's the transmission of the data. So no one can necessarily intercept it with a man-in-the-middle attack or anything like that, right? And feel free to stop me, guys. If you have a question and stuff, I know I'm going through this fast. I'm literally here as filler. So I'm just trying to expand the newbies' minds while we wait for one more speaker to get here. All right, so basics of the standard web as we know it, right? So there's like this monolith, there's like a database, there's servers. Sometimes we split things up a little bit. Sometimes we encrypt things. Sometimes we deal with things in a certain way. But in general, that's usually like the very base knowledge for a backend developer, right? So then we go into things like the modern web, and how does that work? Well, in terms of like Node world, which again I'm referencing in this whole set of slides, is it handles this asynchronous programming. It handles it well. It was designed for this concept, right? And it has different ways of doing this. In JavaScript, we have several ways of doing asynchronous programming: callbacks, promises, generators, async await. And then it handles it using an event loop. In the last talk, I already talked about what the event loop is, so I'm not going to teach you what that is today, right? But it's a special way that we access C++ code, right? Given to us by the Chrome engine, V8, right? Ta-da, right? And I talked to you already a little bit about like HTTP for a second, and I talked about API for a second, but that's not the first, right? I mean, like there's a bunch of other protocols and stuff, but what we use now, I mean, when you saw the picture I had with the header, it said HTTP 1.1 200 OK, and that's the main way we send stuff, but it's not the only way. And honestly, it's probably not the way you want to use anymore, now that it's become essentially standard across browsers. There's a new protocol. It's version 2, right? So the way that you use the internet was essentially invented, or like at least agreed on, in 1996, right? Quite a while ago. I don't know if everyone here was born by then, right? But 1.1 came out a few years later, and then since 1999, essentially nothing happened in the web. A lot of things happened for developers, right, and for companies, and new things they're trying to build. They're trying to build real-time stuff. If you think about a website in 1999, that was a very like GeoCities, very ugly animated fire, like unicorn repeating on GIF repeating thing. It's an ugly, ugly mess, right? That's how the web was. Sure, yeah, exactly, right? Just ugly, horrible things that no one knew what they were doing, right? And so later on, eventually, like through the early 2000s and stuff, people started getting the concept, I want to build something real time. I want to build things like chat apps or video games, other things that I want to handle on the web or through my mobile device or whatever. Remember, iPhones and stuff just came out in the very late 2000 like knots, right? So like 2009-ish was, I guess, iPhone 1 came out. And then these concepts of apps and stuff, we have to be able to handle more data faster, and we have to handle like these TCP like WebSockets. These are a new concept. How do I handle that kind of stuff? Is that the only way to handle it? How how do we deal with like more and more data that's being passed through? It's not just like these small little like 1 kilobyte files anymore. It's these large megabytes files and stuff. How do we handle all these different problems? So Google came in and they said, you know what, we're going to handle this. You know, we're kind of the biggest stick in the block right now. We're going to start changing things, and we're going to make it at least for ourselves. And they created something called Speedy, and that was released around 2009. And they had their own little upgrade, you know, to handle their YouTube stuff and other stuff, to do streaming and stuff, and larger packages and information that they're sending from one point to another. And then finally, the other browsers got around to agreeing onto it for the most part in 2015. So since 2015, not only did you have ES6 for JavaScript, but then you also had a new version of HTTP. And still, most servers, especially here, do not use it. You need to. If you actually check a lot of your CDNs, right, so when you're importing your Bootstrap or your jQuery and stuff, if you open up your DevTools and you look at the sources and the network and stuff, you'll see that things are coming through H2. They're not just coming through HTTP anymore. And so people are trying to upgrade because it's faster, it's nicer, it's got a lot of extra nice features and stuff. And this is completely changing the way we're dealing with things. It makes it a lot more manageable to split up our services even more between ourselves. We can now have different CDNs in different locations, and that's okay because we can transport even more information across the world and get it to people faster. And a lot of other stuff, right? Handling really sucky internet here in the Philippines, on our phones, whatever, right? Being able to deal with that is a huge boon to us, right? And so a lot of people, especially our students and stuff, have no idea what this HTTP2 is. And yes, you do have to do a little bit of work. It just became standard now in core Node literally like a week ago, right? Or 2 weeks ago. So it's still relatively new to a lot of different developer communities. Right, so it's not just like the Philippines is behind. So one of the concepts it does is multiplexing, right? So it's essentially I have 3 different files, let's say, right? 3 different responses, and I can basically send them all at once rather than sending them. I can overlap them on top of each other and send them at once rather than having to request differently for 3 different files. This saves me a little bit of time. It's nice because also, if I have really crappy internet here in the Philippines, I only get so many packets at a time, right? So if each packet contains a little bit of everything, rather than waiting for one thing to come through, then a second thing to come through, this is nice, right? So we can actually just throw a little bit more in at the same time. Especially if this is for but this is for TCP, so it's like streaming, right? So if I was doing like a video or something, video and audio together, right? Rather than just video, then audio. Server push. Server push is another concept where you have to do a little bit of extra coding for it to make it work a little bit nicer. But what it is essentially old web, right? We have an HTML file. It's got a bunch of different imports and stuff and scripts. And so when I have a CSS file, I have a JavaScript file, and I have like an image file. Those things have to be responded to us, to our client, separately. And they take time individually, right? So they take seconds each. For someone like Amazon or something, or Lazada or something, that's literally millions of dollars for every extra second that it takes to load something, right? And why is it that we have to wait so long? These are all usually stored in the same place. It doesn't really make much sense. So then, if you just start using HTTP2, right, it's going to help you already. So it's going to start sending things altogether, right? Because it knows that it's going to parse through everything, and it knows what all the different files you're going to bring in. So it's going to bring in those files for you. It's going to bring in everything that it's expected to, and it'll bring them in together. But you can add something even farther on top of this, is you can do the server push stuff, right? So if someone asks for an index.html, you know they're going to ask for a CSS file. You know they're going to ask for the images in that file. So there's no point even like parsing it just to find out what they're going to ask for. You know they're going to do it, so you're going to just push it to them, right? And so there's different ways of handling this already. Things like for more complex things like like Redis or other things. But just for like handling just a simple website, this saves a ton of time, right? So in this theoretical example, I've gone from 5 seconds to 3 to 2. And so 2 seconds versus 5 seconds is a heck of a lot faster, right? You save the patience of your user, and then you also probably make a lot more money, right? Especially if you have to deal with things like checkouts or different kinds of like shopping carts and things like that, right? Stream priority is not a thing that's absolutely standard yet. It's more of a suggestion than a thing that we absolutely use. So if I have different streams coming in, I can kind of say which one should have precedence if it comes at essentially the same time. and a little bit of other stuff. But essentially, it's still a suggestion, so the browsers really haven't agreed on making this standard. But essentially, you can wait. I prefer this one if they show up at the same time or something. Header compression. Like I said a little bit earlier, a lot of the stuff that comes in through our responses and stuff is not necessary. It's things about like what kind of server is it, or what language it was using or something. Great, wonderful. But I don't always need that. And I can compress down my header and save a lot of room, right? Because the heads, even if you're like, think about like your index.html, right? Your HTML file, that's still space. That's memory. That's stuff that has to be transported. If I don't need to repeat myself, or I don't need to give you information that you don't necessarily care about, then there's no reason for me to do that. And I can save up some time, save up some space in those individual packets that are making it to your phone that's barely connected to the internet, right? Or at least it seems like it. So I can get more across in a very short amount of time. Right? HTTP2 implies encryption. In itself, you do not need to encrypt your websites or your apps or whatever. You don't need to. But at least for web, all browsers demand it. So if you do use HTTP2, you do have to encrypt everything, right? So what's nice is if you're using it and you're facing the web, people will basically have to be encrypted. And the web should be encrypted for lots of reasons, right? Security matters, especially to your clients and your users, right? And now we've gotten into a little bit farther, and this is essentially where we're at now. We have these different services, and microservices are like, the buzzword of the day, right? How big is a microservice? I have no idea. How small is it? No clue. But it's an idea of basically I build lots of different servers, and they're essentially handling different functions, right? And they can be stateful, they can be stateless. I handle a lot of different things, and they're only meant for one thing. So instead of having this one monolithic thing, this one monolithic entity that I had back in the 90s or early 2000s, instead of just having even one server, even with it split up from its database, I can now have different things that handle different things, right? So I have one service for my mailgun. I have one service for our upload, right? We have one service for handling like encryption or something. We have another service that does another thing, right? Handling some kind of calculation. And what we do is we just split these up so that now we don't have to, thanks to things like Lambda and other stuff, we don't actually have to have everything turned on all at once. This can save you a lot of money, it can save you a lot of time, it can save you a lot of calls and a lot of resources too, right? So there's a lot of advantages to this, but it takes a lot more know-how, it takes a lot more DevOps people, it takes a lot more time to get started, right? So there's a lot of challenges either way, right? So there's pros and cons to everything. I don't want to tell you that any one of these ideas is right or wrong, right? It's just an evolution through time based on the demands of the users and the developers trying to solve those problems, right? So that's it. That was hopefully pretty quick. And hopefully I gave the other speakers some time to get here. Do you guys have any questions about the evolution of the web since essentially the 90s to today? Oh, good. You guys are all experts, right? Excellent. OK. I know I've given it to these guys in the front row, right? The seep people sitting in the front row. But I mean, these are new concepts, right? And what I'm saying, and so hopefully a lot of this is review for you. If it is review, good. Go teach somebody else, because I assure you, there's 26-ish million people in this city, and if out of 100% of developers, I'm going to say 96% have never heard most of this. And that's up to each one of us. That's up to all of us to actually go out there and educate, right? The schools aren't helping us here. And a lot of the companies are just WordPress shops that are just like, FTP bucket, hopefully it works, right? So, share these kind of knowledge. If you haven't used some of these things, if you're not encrypting your stuff, if you're not using HTTP2, check it out, right? At least just review it. Go check it out. See if you can split up maybe something for a microservice. What is that, right? Node is good for the microservice thing, but there's plenty of other languages that can use that. There's no reason you have to use Node for anything. So do check out this stuff. If you have any questions for me afterwards, though, talk to me, right? I'm just happy to help you guys learn anything, hopefully introduce you to some new concepts. And that's what we're doing, right? That's the reason of this whole community, right? So we're happy you're here. Thank you all for coming. Hopefully there's more people on the way, right? A lot of people subscribed to the event today. So if you guys have any more questions, talk to me afterwards. Otherwise, we'll get ready for the next speaker. So thank you. Mr. Dean. Mr. Dean Armada. Come on up here, sir.
Let me get prepared first.
Sure. Are you gonna sign up on here, right?
Yeah, Google Drive actually.
Okay, good. I just signed up.
Okay.
We'll probably turn this off. All right. Hi guys. All right. So next speaker up, Mr. Dean Christian Armada will be talking to us about Docker Swarm orchestration.
Okay. Yay. Hello. Oh, how shall I? How shall I turn that to my side? Okay. So good evening, guys. How are you? Awesome. Okay. So I believe we still have. Thomas is expecting more audience, so maybe it's just the traffic. Well, I came from Makati, and it took me 2 hours to get here, so yeah. So I'll be speaking about Docker Swarm orchestration, so yeah. Okay, so let me tell you about myself first. So my name is Dean Christian Armada. So I'm a full stack engineer at Zurian, so it's still a startup company and in the process of building its own software. So watch out for us. And then I specialize Python for backend. I'm a Docker lover. I mean, what can I say about Docker? It automates stuffs, and then it makes deployment a lot of ease. It's a one-fit-for-all environment, and it changes the creation of web application in another level. What I meant is a game changer in creating web applications. So yeah. And I'm also experienced in AWS, Azure, and DigitalOcean. So I recommend people to use DigitalOcean for startups and for maybe beginners because it's a lot cheaper and what can I say? It's a lot easier to use than the two giants, which is AWS and Azure. But for scaling purposes and more advanced stuffs, of course, I'll recommend AWS and Azure. So others will be, I used to code JavaScript. Maybe it's almost about a year when I created a web app front end using AngularJS. And in the near future, maybe I can learn Golang, and yeah, so on. Okay, so the objectives of this talk is for everyone to be knowledgeable on orchestration and to learn the basic concepts of and overview of Docker Swarm. Okay, so what is orchestration? Where did Docker Swarm come from? Components of Docker Swarm, and the last, I'll give you guys a demo. Okay, yeah, by the way, I forgot to tell you guys. I'm not really gonna do any coding or maybe even type a command line because I think those stuffs, the real life demo, are more suitable for courses and training. So yeah, most likely I'll be just showing pictures of what the code does. I mean, it's the same thing. The important thing is the output. So yeah, so what is Docker? What is containerization? Okay, so Docker, the official definition on its website is an open platform for developers and sysadmins to build, ship, and run distributed applications, whether on laptops, data centers, VMs, or the cloud. So building is the part for the image. So you'll build an image, ship it to a registry. A registry is like the repository for images. You can have your own local registry in your laptop or your computer. You can use Docker Hub. Docker Hub is the popular registry and open for everyone. So when you do a Docker pull, most likely you'll be pulling from the Docker Hub. And then run it into a container. Okay, so this is an example of containers. So if you take a look at here, so I have a Postgres container. Sorry for the wrong spelling. I have a Python 2.7 container. That would most likely be Django and an Nginx. So if you take a look at here, it's more modular. So each container has its own app. So what happens here is the Nginx will serve as a reverse proxy to my Django application, and then Postgres is connected to my Django, and it will all work out like that. So yeah, just like that, I already have like a 3-tier web app in a single host. Okay, so containerization is like separation of your apps. So it is also known as multi-container. So using containers as modules on building an application or software. So here is a more complex example. So let's say here I have a database container that would most likely be Postgres. A dashboard could be like created in AngularJS. A messaging container could be like my Node.js API. A reverse proxy will be my Nginx. Message queue could be Python. Online shopping could be like maybe PHP or Golang. So if you take a look at here, it's like a microservice or let's just say multiple services in a single host. So it's almost like microservice, except every resources of this container is still running on a single host. So yeah, it would be great, right, if we can turn this into a monolithic multiple services into a microservices. So Docker Swarm will be the job for that later on. I'll explain it more thoroughly. So yeah. Okay, so one thing to note with containers is once you run a container in a Docker daemon, it will just become a process, and they are not mini VMs. When you say mini VMs, it's like you're referring to virtualization, and what's with virtualization is you set a resource to a specific mini VM or guest OS, and what happens is, or the natural scenario is, not all the resources that you set for that mini VM is used. So, but with containers, they use just a single resource for the host, and they are operating in a single kernel. So yeah. So let's start with orchestration first before we get to Docker Swarm orchestration. So what's the basics of orchestration? So it's the automated arrangement, coordination, and management of computer systems with different services. The traditional way of handling interactions between different services and SOA. There are point-to-point connection between the services. So what does that actually means? Let me show you a diagram for that. So this is an orchestration example. So there's a customer service, and then it will send a request to the service. Yes, a loyalty point service, probably create points balance, and then it will respond. Once the response is successful, it will send a welcome pack. So another request for this service, another response, and then lastly the welcome email. So if you've noticed, what's this? So it's like a sequential HTTP request. So yeah, there's an orchestration. So this is the orchestrator. The customer service, the orchestrator. So it's like a middleware for every HTTP request. So yeah, like what I've mentioned earlier, it's a point-to-point. So yeah, it's like a sequential request for every services in an infrastructure. So this is a more complex this is a more complex example. So it's a point-to-point. So yeah, it's a little bit complicated to look at. So but the point is, it's like a sequence of it's like a sequence of requests to complete probably a process or a service. Yeah. Okay, so finally, container orchestration. So it is the transition from deploying containers individually on a single host to deploying complex multi-container apps on many machines. So like what I've shown earlier, in a single host, we have multi-containers there. So I've shown earlier, like the database, the message queue, and so on. I think there's 4 more containers for that. So what happens with container orchestration is, instead of running on a single host, they will run it on different nodes. When I'm saying nodes, I meant virtual machines or droplets if you're a DigitalOcean guy. But what I'm trying to say is it's across node virtual networks. So yeah. So we really just throw requirements as Swarm in the form of services, and it will orchestrate how it lays all that out and which nodes they need to be, and we just got it. Basically from multi-containers to microservices. Okay, so what is Docker Swarm? So it's a major evolution of Docker. So Docker will not be only a runtime container runtime anymore. A built-in orchestration of Docker, a clustering solution built inside Docker. So containers will be run in a multiple Docker engine or daemon. And then it's not enabled by default. You need to run Docker Swarm init. And then new commands will be available once you initialize Swarm. So like Docker services, Docker secrets, and many more. So it's completely dependent on images, no build. So most likely if you're starting Docker, you will really rely on Docker builds, probably Docker Compose as well. So, but with Swarm, there's no builds. You need to publish those images on a registry, probably on Docker Hub or Docker Cloud, and then you'll just pull it and turn it into services. So yeah. Okay, so what are the advantages of Docker Swarm? So it has a built-in load balancing. So yeah, if you take a look at the diagram, so user is like it's just like a client user. So if you take a look at the container, so this green one is a web application firewall, and it load balances in the term of after his request passes to the firewall, it will have a round robin load balancing. So maybe the first request, or actually the first request will go to this Nginx container on this node, and then the second request will go to this container. So this two manager node will get requests alternatively. So yeah, that's the load balancing. That's the built-in load balancing feature of Docker Swarm. Okay, so service discovery. So for the service discovery, actually, if you've noticed, you could ask yourself by just looking at the diagram, how will this web application firewall proxy to the Nginx, to this Nginx container, and how will it know that it's in this node and in this node as well? So Docker Swarm orchestration has its built-in service discovery. So all you have to do is call their service DNS, service private DNS. In this case, the service private DNS will be Nginx. So yeah, maybe we could call this Nginx port 8000. We can call this Nginx. You can just call like an HTTP Nginx, and then it will already know that that the container is already in this node and in this node. So yeah. So yeah, this is an example of like what the service discovery looks like. So if you've noticed, like I mentioned earlier, I just called the private DNS. So API is like my Django. So yeah, with this one, it will already call. So with that configuration, it already knows that the request will go to this container, which is the API, and second one will go to this second one will go to this node. So like what I mentioned, the load balancing, this will be simultaneous. And with service discovery, it already knows that it will go to this and this. So yeah. Okay, so failure mitigation. So what's good with Swarm is it introduces zero downtime. So in a simple Docker compose or in a simple Docker run, if the container collapses, most likely that's it. But with Swarm, there's a rule or policy in Swarm that if you've like set the replica or the number of containers to be 2, then it will always have 2 containers no matter what happens. So even if the memory overloads, maybe it will find another available node and the container will go there. So yeah, there will be zero downtime. And one more thing about failure mitigation in Swarm, there's a rollback there. So if ever you've deployed a new one, and then for whatever reason, maybe you forgot a semicolon, it fails, then it will just roll back to the latest version of the image, and then your app will still be up and running. So yeah. Easy to scale. So when I meant easy to scale is, in Swarm, it's not, we're not talking about containers anymore, but rather services. So when we're talking about services, there are replicas. So when you define like a replica of tree for that certain service, let's say the Nginx is a replica of tree, then it means that it will create 3 containers. So when I say easy to scale, then you can just add more replicas to that and then maybe put that replica to another node. And yeah, so there, the load balancing will serve as the scale for there. Okay, so components of Docker Swarm. So how does Swarm actually work? So node. Let's start off with the nodes. Like I've said earlier, nodes are the VMs or the computers or the machines. Okay, so in this diagram, the nodes are these ones. So manager node, worker node, leader node, and so on. Okay, so there are 3 types of nodes in Swarm. So first will be the leader node. The leader node is the primary manager node. So it is the main. It's the main man or the main node for for the Swarm management and the orchestration part. So yeah. So the manager node, second will be the manager node. Manager node has a built-in graph database. So what's stored there is the configurations and information to make everybody know in the Swarm that they are the authority. Okay, so manager nodes can also be worker nodes, but the difference is they have privileges. So they can run the Docker Swarm commands like Docker services, Docker stacks, Docker secrets, so on. For the worker node, the main difference between the manager and worker node is they don't have any power, so they cannot run any Docker Swarm commands. Yeah. So this is the manager and worker. So if you can see, see, they have the certificate authority here, so which gives them the power to do some Docker Swarm commands, and this just workers just waiting for their managers to give them a task or any commands. So yeah. So every node's manager, workers, and leaders, they all run in the same location, which is called the universal control plane. So yeah. Okay, so this is another sample for managers and workers. So if you've noticed, managers separated to workers. Managers is located or grouped in a RAF consensus. The purpose of that is for them to have for them to know for them to maintain the global cluster leadership. So if one manager or one leader goes down, another manager will be voted or elected to be a new leader, so the swarm wouldn't go down. So yeah. And here are just workers, like I said, they're just waiting for tasks to be assigned to them. Okay, so yeah, that's for node. Now for services. Okay, so so in this case, everything here is services. So this is the Nginx service. So I decided, or I set the replica of the Nginx service into 2, for the web application firewall into 1, yeah, and the API for 2. This is the scraper, and then the database. So yeah, those are example of services. Okay, so there are 2 types of services. So replicated is what I've been mentioning since earlier. Setting services into a replica. So it's more flexible using replicated, because you can set how many services that you want to use. So maybe you can set it into just 1 replica, 3 replicas, 2 replicas. So yeah. But with global, it simply means that every node that you join in a swarm, there will be a container for that node. So yeah. Okay, so this is the concept of a swarm with replicas. So yeah. So if you did this command, Docker service create replicas tree Nginx latest, so you can only do that, I repeat, on a manager node. So if you do that command here, it will search for for available nodes, and it will assign those tasks or container to those nodes. So see, so one node here will have a container of Nginx. The second node here will have an Nginx as well, and the third one. Okay, so quick and basic understanding on how manager and services work. So basically, this is a diagram or a picture of how manager works in the background. So in the API, accepts command from client as create service objects. So yeah, so on. Okay, so now we'll go to the secret. So secret is like the standard of Docker Swarm on how to keep sensitive data. So what will happen is, if you assign a secret, it will be contained in a text file, and then it will be put in a folder named secrets, and that folder will be just assigned to containers that you assign those secrets to. So yeah. So this is an example of secrets. So see secret keys here, and since I assigned that to Nginx, actually these 2 keys, we can consider this like the configuration file for the Nginx and the SSL. So these 2 keys will just be in this container. So yeah. And then lastly will be the stack. So if we have Docker Compose for running containers, then we will have Docker Stack for Docker Swarm. So basically, it's like Docker Compose. You put all the bundled services in a YAML file, but this time with Docker Stack, you can only use that. I mean, Docker Stack is for Docker Swarm instead of Docker Compose in a normal Docker daemon. So yeah, this is an example of, oops. So this is an example of stack file. So yeah, these are my images. If you notice, there's no builds here. Yeah, networks is important, and this is a special command. So deploy. I set this database to have 3 replicas. So if one goes down, I still have 2 more, and another one will rise up. So since I set the replicas to 3, it will always have a 3 container on the swarm orchestration. So yeah, update config parallelism 1. So it means that you will only update 1 container at a time and then update all the rest. So delay of the updates, restart policy, mass attempts. So yeah. Okay, so one, like I mentioned earlier, in Docker Swarm there will be new commands. So Docker Swarm here, this command will have options of initializing the Docker Swarm, and then will produce tokens for other workers. Okay, so yeah, I'll just quick things up. Okay, so Docker Swarm will have like the options of for producing tokens and initializing the swarm. The Docker node is, you can have an option of listing all the Docker nodes available. For Docker service, you can like create or update or even listing the services. For Docker secret, yeah, like I mentioned earlier, also the Docker stack. Okay, so demo time. Okay, so yeah, like I've mentioned earlier, I'm not really gonna do some coding or even command lines, but rather I'll just show some pictures. So what you see here with the highlights is I created 3 nodes. So all of them are in DigitalOcean because it's really cheap. Yeah, it's just a $5 per month node or droplet. So yeah, see, 3 nodes. And then now for setting the swarm. So the node 1 will be my leader node. So like I said earlier, there's a Docker Swarm in it. So it means that I initialize the swarm. So, and then it will produce a token. So how did the other nodes join? As we simply just input this command, Docker Swarm join token. So they're already part in the swarm, this node 2 and 3. Okay, now for the deployment. I just checked out and make sure that I have the 3 nodes. So there it is. So node 1, node 2, node 3, all of them are ready. Node 1 is the leader. And then, like Docker Compose, like I mentioned earlier, if a normal Docker daemon has Docker Compose, then we have Docker Stack deploy here, and just one command, and everything will now be set up. So the networks and services will be created. So yeah, and then I just check. Let's check if the services are all up. So yeah, I created 2 replicas of API here, 1 web server. Visualizer is like the it visualizes the overall on, like, I have 3 nodes and then which container is in those nodes. Thank you. So let's just see what happened with those commands. What's the output? And basically this one. So I didn't set any front end. It's just a normal Nginx on the port 80. So maybe I can put a front end there. And if you take a look at port 8000, oops. So this is my Django app. And for the visualizer, to see or monitor our swarm, yeah, it's port 8080, by the way. By the way, guys, do you have questions? Yeah.
Could you pass the Docker secrets as like current variables? We use them as current variables.
Yeah, of course. Yeah. Oops. What happened again? What do you plan to use those environment variables for? So like AWS access key, something like that?
Yeah.
Yeah. Yeah, of course. Oh my God, why is it turning like this?
Why use Docker Swarm instead instead of K, Kubernetes?
Kubernetes. Actually, that's a tough question, but I haven't used Kubernetes myself. But what the advantage of Swarm is, that is what the Docker community is focusing for. So if you take a look at communities or threads, they really are recommending Swarm to be used on productions. So yeah, Kubernetes is also an orchestrator. Probably it came first before Swarm, but a lot of Docker engineers is like using Swarm or really developing Swarm. And if you take a look at Docker Cloud, Docker Cloud, by the way, is the cloud infrastructure or the cloud service of Docker. They have like a built-in Swarm service there. It's still in beta, but what it does is you can easily or create a swarm of nodes clusters. You'll just have to connect to your cloud providers, which is currently just AWS and Amazon, to create your own swarm. So yeah, and wait, let me do another. Well, anyway, what happens there, or what? Yeah, just find out. Oops. Yeah, actually. Yes, actually I have this. So guys, it's small, but basically it shows this. So I have a 3-node swarm here. I have a 3-node for my swarm, and then it shows all my containers. See, so for node 1, I have my web server and visualizer here. And then, yeah, my 2 API containers here, and my DB here. So it also shows the remaining memory resources for each node, and yeah, the image metadata. So yes, simply that's it.
Thank you, Dean.
Okay.
Excellent, excellent. Got to get more into Docker Swarm. All right, guys, next up we have, and we're going to go over a little bit today. Sorry about that. We're going to go next with Caleb Fornari, the birthday boy himself. He'll be speaking on provisioning services on AWS ECS with Terraform. Oh, we got pizza, so he's got setup time.
Yes.
All right, guys. While he's getting set up, go get you some pizza. Get you some drinks in the back. Hooray! The sweetest that I've ever seen. All right, everybody. You had some pizza. You had some drinks. Congratulations. Get back to your seats. All right, guys, next up, like I said, Mr. Caleb's going to be talking about ECS Terraform, right? Okay. So, Mr. Caleb, if you want to take it away. Thank you, sir.
Sure. All right, just a quick introduction. Caleb Fornari, CTO of Startups Group. We do sort of manage DevOps and a lot of infrastructure automation type stuff. Today I'll be talking about managing ECS containers with Terraform. Sort of a combined case study of best practices, tips that we've learned when implementing projects for various clients. So it's not really any specific project, but more of a combined set of things that we've learned over the years working with ECS and with Terraform. So first off, how many people here have used Terraform or have heard of Terraform before? Okay, very good. For those that haven't, I'll just cover what it is real quick. It's essentially a platform and a tool that allows you to define your infrastructure as code. There's a heavy focus with Terraform on AWS, but it does also support Google Cloud, Azure, Kubernetes, Docker Swarm, and others to varying degrees of completion. So, Google Cloud is fairly good, Azure not quite as good. Kubernetes is very, very, incomplete at this point, but it is being worked on. It's an open source tool developed and maintained primarily by HashiCorp. You may know some tools like Vagrant, Packer, Vault, Nomad. They're the company behind those as well. Looks like the screen ratio is cutting off the bottom here, but there is a link here to the complete list of Terraform providers. I will link this presentation in the Facebook group afterwards, so you can go there and grab those links if you want to. And secondly, what is ECS? ECS is actually Amazon's or AWS's version of Docker Swarm. So it's essentially an API on top of Docker Swarm. It enhances the functionality of Docker Swarm a little bit, provides some deployment tools, and integrations with the rest of the sort of AWS ecosystem. Things like networking and stuff like that, load balancers, for instance. They all integrate sort of with ECS, allow you to run your containers, automatically register them to load balancers, stuff like that. It is not a fully managed platform, so it does require you to maintain your own cluster of servers. So you're going to be setting up your own cluster of servers, and essentially you can use Amazon's pre-built AMI or build your own, and then set up an auto-scaling cluster which will register essentially every instance to the ECS swarm when they boot up. Why Terraform with ECS? Primarily just because of the support. So Terraform and ECS work really well together because Terraform is more or less feature complete on Amazon, excepting some of the really new services. It's an especially good option if you're already on AWS or already using Terraform for some other stuff. If you're on Google Cloud already, you may want to consider their container engine. Users of Kubernetes obviously will want to stick with that platform. You can also tie multiple clouds together or multiple infrastructure providers with Terraform. So you could use AWS plus Google Cloud or something like that. It's not really recommended, but it's completely possible. An example of something we have done before is tying like an Amazon or AWS VPC or network together with a Google Cloud network. And Terraform can actually set up a VPN between the two automatically, and using the integrated like VPN capabilities of Google Cloud and AWS. Best practices. So maintenance with Terraform can become a major issue pretty quickly. To sort of keep things maintainable, it's really important to essentially focus on three things. So State in Terraform is the concept of what is actually on AWS right now. It sort of maintains, it's a custom format from Terraform, but it maintains essentially a list of objects in AWS, values associated with those objects, things like that. You can use Terraform completely locally, so just on your local machine, but I highly recommend pushing your state using the sort of the backend state provider up to some sort of store like S3. That's the most common one. There's a bunch of other state stores that are supported, but S3 is the easiest sort of default option. This also has the advantage of allowing multiple developers to work on the same project. If you're both pushing changes at the same time, it will actually lock the state until one developer's changes are complete before it will run the second set of changes. Second thing to think about when you're thinking about maintainability and designing a project is layers. So with Terraform, it's really easy to sort of add everything. So your VPC and then your auto-scaling clusters, your application servers, et cetera, all into the same project. But if you do that, you'll actually eventually end up with a situation where you have this big monolith, and making changes, it sort of tries to pull in the state of everything in your AWS infrastructure at the same time. So instead, it's better to break it down into layers. So you can break it into like a VPC project that just creates your networking, your subnets, your VPC in AWS. Create like an ECS cluster project, for instance, that just creates your ECS cluster, and that can actually import values from the VPC project. So you don't have to maintain like lists of VPC IDs or subnets. That can actually be imported automatically into your ECS cluster. This gets especially important when you're dealing with multiple environments. So you can maintain a list in Terraform of multiple variable files, essentially, for different environments. And then those can be associated with various clusters. So the same Terraform project can actually manage your development environment, your staging environment, production environment, and this keeps everything sort of identical across environments. It also makes it easy to sort of promote changes from one environment to the next. So if your Terraform state is managed remotely, you'll be managing essentially one state for each environment, and then you're going to have a separate set of variables associated with each of these. Don't abuse the variable files, just because if you start adding too many variables in here, then maintenance again becomes an issue very quickly. You want to keep this to sort of the minimum set of values that are different across environments. And then you're going to, of course, need to push your images, Docker images, to a repo, which ECR is essentially the like ECS-friendly AWS version of a Docker repository. So you can push your images there, pull your cluster can pull your images, and then you can maintain them as sort of this environment-specific set of values. I already talked a little bit about the remote state backend. So this is just a list of different backends that are supported. There's an enterprise option if you want to sort of pay for Terraform's premium support, but otherwise you can use sort of any of these data stores. Essentially anything that can store files or values can can integrate with Terraform. You can store your states there. This is just going back to the concept of layers that I mentioned earlier. So, in this specific project, if you're running an ECS service, prerequisites would be your network, your VPC, then your ECS cluster, and then the service, of course, runs on top of the cluster. Service can be a collection of multiple containers or a single container working together on the cluster. So, if you're just running a simple web server, you can load that up as a single service. But if you want to run a full application stack with databases and all those things, you can do that as well. This is just going back to the environment variables that I mentioned earlier. So you can actually pass these in at runtime. Unfortunately, I don't have my local machine wasn't connecting, so I can't show you an example of what this would look like on the command line, but it's basically a command line argument where you can pass in the environment-specific variable files that you want when you run your project. And this enables you to sort of manage, as I mentioned earlier, multiple stacks or multiple environments, keep them essentially the same, but with deferring values where needed. So basic Terraform workflow. Anytime you're working with a Terraform project, there's 3 basic steps you're going to go through to get it running using this sort of layered model. First, you're going to init your project, which basically means you're going to pull down that remote state file stored in S3 or whichever backend you want to store it in. You're going to actually pull that down to your local workstation using the Terraform CLI tool. And that basically collects the state data and applies it to the current workspace, which means the state of your workspace on your local machine, if you've made changes, say, to the Terraform definitions, which define your AWS infrastructure, it'll check against your state. So your state is what the last state of the known changes on AWS. It'll check that against your local setup and then compare the differences. When you run plan, once you've initialized your environment and it knows which backend or which state it's working with, this will actually compare to the AWS environment that you're working with. So rather than just checking against your local machine, this will actually go out to AWS and look at the difference between your state file and what's actually in AWS. And then it will output a list of changes. So whichever differences it sees between your local environment, your previous state, and current state of AWS, it tries to make those consistent. And it will tell you, I'm going to make these changes, I'm going to delete this, I'm going to add this, things like that. And then apply, pretty self-explanatory. It will actually apply those changes and output the result if it was successful, if it failed. Any changes that it does make, it will output those as well. This is just going back to the concept of backend. So your backend, whether you're storing it locally or on S3 or another provider, it never actually, or your AWS infrastructure is never actually aware of the backend itself. So that's all managed by the Terraform command line tool. So it may be reaching out to AWS, to S3, or wherever you're storing your backends, but it's mediated by the CLI tool, and the CLI tool is comparing that current state with what's in AWS and then making the changes there. So there's no direct connection between the two. I do recommend using different keys for various environments, so making sure that you can't accidentally apply changes to production. If you accidentally initialize the wrong environment, make sure you have some kind of safeguards in place to prevent that kind of issue. The way that you actually import and or export values from Terraform is through what's called an outputs file. So for any given project, you can output, say for your VPC, you could output your VPC ID and subnet IDs. You do have to explicitly output those in order to import them into another project. So you have to be thinking about, with your VPC, for instance, which values do I need to use for my ECS cluster, for example. ECS cluster would need the VPC ID. It also needs to know which subnets it's going to be running in. So you could output those, import them into the ECS cluster, and then when you actually want to run a service on your cluster, you can actually import that into the ECS service, and then it knows the values of the cluster and service names, things like that, and will run on there. You can import from multiple projects into a single project. It's not a great idea. Whenever possible, you try to stick to like a single import per project. If you start importing multiple, it ends up with a lot of dependencies and things can get a bit confusing. I was going to do a quick walkthrough of the repo, but I think we're running out of time, and you know, it's like I said, I don't have it on this machine, so we'll skip that part. The example repo for this, kind of showing these concepts, is up on GitHub. So as I mentioned, I'll link this presentation in the Facebook group. You can go there, check that out. I also highly recommend.
Is there an equivalent to Terraform that's not AWS?
Terraform is not specifically AWS. It does support other like cloud providers, other backends, things like that. It's actually maintained by HashiCorp, so it's not really AWS official. There's not really a great alternative to it that I know of. It's really a very dominant market leader in its space. You know, other things like Docker Compose would compete with it in the Docker space, but there's nothing else that really covers such a wide range of, you know, services, clouds, and infrastructure like Terraform does. There are definitely competing projects, but none of them have gained real significant traction. So, you know, you can look around, like there's other open source things, but they're just not really complete yet or production ready.
How do you compare Terraform with tools like Chef or Salt or Ansible?
Sure. Chef, Salt, Ansible are essentially, you know, configuration management providers. So Salt or any of those really would take a current server or current infrastructure. Say in AWS, you create a server, you register it with your Salt master or with your, you know, Puppet master or what have you, and it would actually add applications to that server, configure that server how you need it. Terraform is what actually creates or could actually create the server in AWS. So you can do that, like Puppet and Chef are moving into the space. Exactly. But they're not going to support sort of the range of things that Terraform would. So Terraform can handle your networking from the VPC layer all the way up, whereas typically with the configuration management providers, you're going to be dealing more with just spinning up like auto-scaling clusters or things like that. So Terraform tries to be a little bit wider in the breadth of things that it can handle. Sure.
How do you handle the service discovery? Terraform and
ECS has sort of rudimentary support for service discovery. You can register services to load balancers, so you have sort of a static URL, and those services will self-register if, say, a node goes down in the cluster, a new container spins up, it registers there. So you have some level of service discovery, but if you want sort of you know, more service discovery than what you get out of the box, you can run something like Console. That's from HashiCorp, or you know, Docker Swarm built-in service discovery works as well. There's a lot of options there. Terraform doesn't really manage or handle service discovery for you out of the box, and ECS is relatively limited in what it can do. Anyone else? All right. Thanks, guys.
All right, thank you very much, Caleb. Next up, we have Fabio Brito. He's got the home field advantage. And Fabio will be speaking on production engineering, or how ops can help business. All right, Mr. Fabio, the floor is yours.
Hello, everyone. First of all, thank you for coming. I try to be quick on this presentation. I believe everyone is already tired and so on. My plan is to, for this talk, is to avoid to talk technical stuff, but more like cultural content. So I'd like to explain about the production engineer and how ops can help the business growing. First of all, let me introduce myself. I'm Fabio, I'm from Brazil, and just joined Split Media Labs in beginning of this year to help they grow this awesome product called Exploit Player Media and Challenge. Basically, everything that relates to game. I've been a sysadmin since, I don't remember exactly, but in the end of 90s or so like more than 20 years. And now, what is production engineering? According to Wikipedia, it's a combination of manufacturing technology, engineering science with management services. Okay, but what really is that? Trying to try to explain it briefly. By the way, if someone doesn't understand me, just interrupt me, okay? That's fine, because I believe Brazilian accent is hard to understand sometimes. So production engineering, it's a way to engineer how, it's a term that comes from manufacturing, that comes from factories, that basically it says how to improve the output from a factory, yeah? And how does it apply to what it has to do with DevOps? If you think that a company, an IT-related company as a factory, okay, it has outcomes. Yeah, basically it's, in our case, the outcome is the product that we are offering to our users. So what has to do with DevOps is basically when you plan your production environment and you automate stuff, yeah, you could bring it to better outcome. Okay, speaking that way, what's production? Yeah, what you can think about production is just on the environment, the living environment. For me, I believe production is everything that bring revenue for a company or doesn't make the company lose money or time. So with this argument, I would say to you that development and staging environments are production too. Because if development and staging breaking, probably the company has lost money because developers can't work. Okay? Just to understand you guys here, who is from the ops side of the force? Who comes from ops? Not that much. Most of them are developers. But I believe developers can get some insights from the production engineering view. Okay. Talking about that explain about what's production engineering. What is really the production engineer? What this guy, the production engineer, does? It's a jack of all trades, master of none. Basically, a guy that knows lots of stuff, but not a master of no one of and stuff. So I came with this. Basically, a production engineer is someone more instead of a person that has a very deep knowledge in an area. Is something like a T, yeah, a T-shaped professional. It's someone that knows lots of technologies, but not so deep, but know at least one technology very deep. Okay, I put sysadmin in the middle because I'm based to be a sysadmin, yeah. But what can bring a good production engineer is a production engineer know about programming, security, database, monitoring, And this bar on the T could grow until the infinite, because you can put other skills on that. Especially if you count some soft skills like business related, like time management or budget or something like that. Yeah, any skill that you have, it doesn't matter how deep it is. It's good to have to work in a production engineer. So some production engineer is someone that has a broad view of the business, but has at least one thing that guy is very good. Yeah. So coming with that, when I was in Brazil, I was managing a team that we called production engineer team. Yeah, and I create a document that what I define to be the production engineer mindset. Basically, I came with these 4 pillars: communication, improvement, automation, and prediction. Let's see about each one in the next slides. About the communication, I believe communication is one very important stuff, because everyone in the company must know what's happening, what's going on, what's new is coming, what's broken. Yeah, because with communication, you can take action fast. And when I'm saying communication, it's not only to have a chat open in Slack with everyone. Communication is beyond the chat or email or stuff like that. It's to have the information available. It can be in a dashboard or in a status page. Anyway, it's very important stuff to have everyone in the company in the same page as you, like what improvement you did for the infrastructure, what is broken at that time. Improvement. Well, there is no perfection. Yeah. So one of the thing that I would say is you must improve every day, not only the product that you were working or the infrastructure that you're working for, but you can improve process, you can improve tools, yeah? But the most important is to improve yourself. Yeah, it's as I said, production engineer or someone with production engineer mindset is someone that has knowledge in all fields. So you must improve what to do with your knowledge every day. Yeah. So one question that you should do every day is what I've improved the last day. So you can always keep improving. Yeah. And one thing that I believe is very important about improvement, improve the daily work is more important than do the daily work, because do the daily work can be done in other ways. But when you improve it, it can be done faster or cheaper or with other benefits. And one other topic about the production engineer is automation. Okay, you should automate. That's what I said about improvement. Automation is a way of improvement. Okay, if you have something that you can describe it as a process, it has exactly steps to be done. It's a candidate to be automated. You can automate. You don't need to have a big project to automate. You can start automating with small stuff, like just writing a shell script, for example. Or you can, if you have, but while you grow, you can use some other tools like Stackdown, that is a framework for automation, to automate what we'll be doing. So the motto is work smart, not hard. Yeah. So that's why you should automate everything. And the other point is prediction. You just don't do guesswork. Okay, like if something needed to be done, trial and error is sometimes that's the only way to do stuff. But the point is, it's not the only one. You have to predict what should be done, and how can you do that? You need to start measuring all the components that you have available. You have to measure your variables. You can use tools like Prometheus, for example, that you can use it to instrument code, or you can use it to get to monitor systems, and you can measure some stuff like response times, uptime, error rates, and stuff like that. Or you can use to measure, for example, just the revenue rate, for example. Yeah, that would help the company. So when you start to measure everything, you can have a trend how that metric will grow or shrink, and with that you can go on the right direction. Yeah. So how this stuff that I talked can help the business grow? Well, as explained, with all these pillars that I stated about the production engineering, when you automate stuff or make everyone the same page as you, or start to measure stuff and to use that metrics to go on some direction, the business can make decisions faster, or it can have more revenue based on automation, because you're not expending your time doing some repeatable job. Yeah, it's automated, so it's more what do they say? It's more faster to get revenue. Well, everything was just to say thank you. Well, I told you that would be quick because we are running out of time, and to say that we are hiring. Yeah, Henrik came just in time. So guys, if you want to join us, just go on that link. And Henrik?
Yeah, I can say a little bit more about it. Like, so yeah, thanks Fabio, and like thanks for everyone coming here today, and thanks Thomas for always arranging these good meetups. It's super great. What was I doing with this measuring band here? Measuring out tables, because we are hiring more people. Now, instead of trying to recruit you guys that are there, all we want to do is just tell you about what positions we actually have available.
What I said about measuring stuff.
So, you know, if you have some friends that you think might be interested in some of our positions, then could we go to speedmedialabs.careers.com? Or speedmedialabs.com/careers, right. Can you go to that link? Just put a screen capture. Oh, good. Oh, it's from here. I thought it was centrally controlled stuff, you know. Yeah. So anyway, we have a range of positions, and we're sort of like we're in a position where we have to fill 12 to 14 developer positions within the next few months, so we need a little bit of help to do that. So if you guys know somebody who could fit the bill for some of these positions, we'd super much like your referral. And for the next, until October 15, I think it is, we do have a referral bonus award, which is 100,000 pesos for any referral that we actually choose to hire. And the way it works is that basically if we get to that website, yeah, for example, let's take a look at, just click Node.js and React, for example. The second one. Or the first one, doesn't matter, anyone. Yeah. You can see that you can actually, if you go down from here, Can I put the arrow down? Yeah. Just go down. Yeah, so it's a description of the position here. And there's also a referral here. So for example, if you know somebody for some of the positions we have, the developer position on our website, let them know they can apply on our website and basically add your name and an email as a referrer. So this is something that we don't usually do because we have a lot of people who generally want to get hired here, and we think we have a great culture and a great place to work and a lot of things to learn and everything else. But with the amount of people that we have to hire within the span of time that we have, so we've asked for help from our own employees to basically reach out to some of their friends, and we're just asking you to do the same thing in case you guys are interested. So the conditions are, be happy to send out a mail, or I think Thomas can send out a mail to you guys after the day to sort of like really reiterate the conditions for the referral fee. But generally speaking, anyone who applies that puts your name and email in the application and actually gets hired, then you'd get 100,000 60 days after the person starts, unless he's no longer here after 60 days. So it's pretty much as simple as that. And yeah, certainly, I don't know how much do you guys know about our company already? Does anybody know about our company and what we do? Okay, just a few. All right. Well, anyway, before actually, asking some of your friends to maybe consider this, you guys could just browse our webpage a bit and take a look at some of our products. But generally, we have 3 major products that we're working on. One is called XSplit, which is actually the application that is also helping us to show this screen right now. And it's one of the, I would say it's probably the most popular commercial broadcasting application in the world. It's used by around a couple of 100,000 new users every single month that start broadcasting, going live on Twitch, YouTube, and other live streaming services. Mostly broadcasting gameplay. So whenever people start playing games, they build a presentation and broadcast showing their game, their camera, and other kind of stuff, and broadcast these services. The second app that we're working on is something called Player.me. It's also live. You can see it at Player.me. And it's sort of like, let's call it a social network for gamers for now. But it's something that we're expanding rapidly over the next period of half year to a year or so, releasing new features and also creating a desktop app with some of the same features that XSplit also has inside. Challenge is the world's biggest bracket tournament organizer, if you will, I think, in terms of visitors and tournaments created. We create more than 80,000 tournaments every month. So, and mostly all our products are pretty much focused on gaming. So that's also one of the things we like a lot. If somebody's into gaming, have a good understanding of the field and so forth. But yeah, feel free to reach out to Thomas. Thomas knows a lot more about the company than most, so he can certainly tell you about that as well. And yeah, that was a short message from here. Hope to see some of you again in some future events. If you guys have actual questions, you're welcome to come to me or ask Thomas afterwards. Is pizza already? Was that served already? Is there something left for me? All right. Anyway, thanks a lot for coming, and thanks, Thomas.
Thank you very much. All right, guys, thank you very much for coming, and thank you very much to Split Media Labs, right? It's a very generous company, but also a very fun company. You see the people in the back, right? These are the people who work here. They're nice people. They're smart people. So do discuss things with them. Do talk to them. Ask them about different concepts or what they're working on. You saw some of the different technologies they're using, right? So, and if you do have a friend, obviously in your interest to go help that friend out, right? So, guys, thank you for coming out. The next time we're going to be having this again will be in probably November, and it'll be at Nokia up in QC, farther up. So. If you guys have questions, feel free. And these guys are on the group and stuff. They're on the meetup. Ask questions through the comments there and stuff. I'm going to post. I know Caleb's going to post his talk for today. If the other speakers will give me their talks too, I'll post theirs as well. And I'll be posting the job listings and the referral stuff, right? So, if you guys have any more questions, yes, sir.
When's the next one?
It's going to be in November. Probably the 3rd week of November, farther up in QC near Diliman. But Because I'm out of the country in October, so sorry. But yeah, we're going to keep trying to have this as often as possible. And hopefully keep learning, right? We want people to learn about these new technologies. DevOps is growing. Backend, we need smart people, right? Security is a huge issue. Getting people interested in these concepts and going far beyond, what the average WordPress developer knows and does on a daily basis is useful and helpful to a lot of people. All right, so thank you guys for coming out. Meet the people in the back, talk to them, meet some of the speakers and stuff, talk to any of us, and let us know if you want to speak for one of the next events. Okay? Thank you guys.